My name is Steve Bonner. I'm the Vice President of Engineering at Northern Neck Electric. I've been here 11 years now. And Northern Neck is a small co-op in rural Virginia and about an hour northeast of Richmond. And we have about 20,000 customers, and our system is about 2,200 miles of distribution line. And we have 20 substations on our system. All of those substations have transformers in them, and most of them have voltage regulators as well. We sample all of our vital equipment on an annual basis. That includes transformers, voltage regulators. We pull little samples. And I have trained substation technicians. I send them out to the substations, and they go to each transformer and regulator, and they pull a oil sample. And the oil that they take is used for different types of analysis, including dissolved gas analysis, or DGA. Once we pull the samples, we immediately pack those safely and ship them to our testing lab. And as soon as we get the test results back, we can import those ourselves and then upload them to the TOA software. And I mean, it's a matter of minutes. The data is uploaded to TOA, and immediately it runs analysis on them and provides results of their analysis, and we can begin to immediately evaluate the condition of the equipment that we have. Well, Delta X, they're the company that's created the TOA software, and so we started using about 5 or 6 years ago. I tell you, it really makes things easy for us as far as consolidating the information we have and organizing it in a way that we can evaluate it. Prior to TOA, we've always pulled oil samples, but quite often we didn't know exactly what we should do with the results. I mean, we have files full of hard copies of test reports that we received back from our test laboratory, but with TOA, we can upload all that data. It comes formatted for TOA from our provider, so they've worked together to create that link. So when we upload it, it's already formatted the way it needs to be, and TOA can immediately bring in the data and analyze it. And what it does is it tracks all that data for us over the course of time. So every time we take a sample and upload it in the TOA, that data goes there and it stays there. And it can, for us, we can evaluate the historical data. We can look at each year and see the trends of how the gases have grown. And we can also look at the analysis that they do with the reliability DGA analysis that is available in TOA. It not only looks at the growth of the gases, which is a sign of, pending problems with the transformer, but it also, it looks at that data and it sees how the trends change and how the rate of change in the growth of gases. And it uses that information to model it and predict what is the possibility of a future failure? What is the type of problem that we're encountering? Is it a partial discharge? Is it a thermal issue within the windings? And it's able to predict that for us and give us better understanding of what the problem might be and what we should do to try to remediate it. It helped us to organize our information. It helped us to put it in a format where we could easily evaluate it and actually make good use of the results that we had. We had good results prior to that, but we weren't taking advantage of that information. Obviously, it's much easier for us to look at an analysis that it's done. It's taken into account industry standards for gas analysis, and I'm not a chemist or a scientist. And my expertise is certainly not gas analysis. So we depend on the TOA to say, hey, you got this gas growth, and these are some of the conditions that are related to that type of gas growth, and some of the concerns that you should have. It's an economical software, and for the value that we've gotten from it, we wouldn't continue forward without it.